I'm Maggie Franklin.
I'm Dan O'Brien.
And I'm Daniel Haberk.
And we have been working with Jordan Anderson in the VA Medical Center to develop a fast and simple way to transport IV pools. Currently, IV pools are transported strictly by pushing them, and since someone has at most two hands, that allows for at most two IV pools to be transported safely at once. And we all know time is crucial in a hospital setting, so we we all know time is crucial in a hospital setting, so we wanted to try to speed up this process to be able to transport more than two IV pools at a time. There have been instances where people have tried to speed up this process and push more than two IV pools, and this often leads to damages on the devices that are attached to the IV pools. So in order to not only save time for transportation of these pools, but time for fixing the damages done on the devices, we have developed a simple and fast way to transport IV pools.
Yeah, so our approach to the problem of how do you transport more than two IV pools safely and quickly in the hospital setting, we came up with a couple of different ideas. We first started off with a containment system for the equipment itself. We found out that that was a fairly ambitious approach because it's really hard to standardize the size of hospital equipment, especially on an intravenous pole. Next, we approached it with a cart idea, and then we decided that adding more wheels to the situation wasn't going to fix the problem, it was just going to make it worse. So what we came up with was this magnetic arm system. In our system, we have two pieces. I have them right here, the basic prototype of them. So we had the central mount piece that we designed, which worked in tandem with an already existing product. This is made by OmniMed. It's a universal IV pole clamp. What we found when we went to the VA to see, get a better idea of the environment and the equipment that we were working with, we found that not only are IV poles not standardized, they are also large, and a big challenge for us was making sure that the system that we create wasn't too large for the hospital setting. Now, hospital hallways we found standardized about 8 feet wide, so we didn't want our system to take up more than half of that. So our central mount is here. Unfortunately, due to 3D printing capacities, we actually designed this to fit inside. 3D printer printed a little too large, so it doesn't quite fit. We're going to go back and revisit that. But this is our central mount system. It has a spot for 3 arms for each IV pole, meaning that each IV pole can pair up to 3 different IV poles, 3 different other IV poles. And on the end, we also designed magnetic hand systems, and we'll call these magnetic A and B, polar and negative sides. And when you link these together, they stick. Now, this creates a cart pushing system of 50 pounds force pressure because each magnet itself, each connection is 25 pounds force pressure. And with this, we are hoping to create a modular cart system for both transport and storage of the IV pools in the hospital setting.
All right, so moving forward, there are a couple of key features we need to add. Firstly being we need to, can I see that?
Yeah.
Make this outer pole telescope with another arm so that the magnetic housing itself can rotate, and that will allow any arm to attach to any other arm seamlessly and easily. And secondly, we need to add a silicone coating around the magnet housing and the base of the arm. That will prevent the magnets from chipping when they connect to each other. It will also help prevent any pinching when you use the device, and it will also create a nice seamless surface for easy disinfecting and cleaning because we are in a hospital setting. That's it. Any questions?
Just a thought. You can avoid that problem by sink the magnet a little bit lower below the surface. So kind of
for the contact,
yeah.
So we wanted to make sure that we had maximum surface area to increase.
But the coating will also reduce the.
Absolutely.
Right.
We could use that as a buffer between the magnets themselves.
Yeah, the magnets are plenty strong to do what we need them to do, so the coating won't take away any strength of the system. It'll just.
Another way is you can, because these neodymium magnets they're brittle.
Yeah.
What you can do is you can put a piece of steel plate, a circular disc over that to protect it. You
Yeah,
will not
that's
reduce,
another option I would also
you will not
look at.
reduce the magnetic force.
Yeah.
It's definitely something we could look into.
Have you thought about a release for that? I saw you trying to pull that apart.
So what I was actually, before, we actually had to change the design. The inner plug on the hand is actually a little bit too small right now. This is just for prototype purposes.
Yeah.
I actually went to take it apart as you were intended to earlier, and I snapped this one. It's super glued right now. So I would have done that in front of you, but I don't want to, seem too crazy. But yeah, that is definitely, no, that is definitely an approach. We want to make sure, especially for the telescoping arms, the larger the system is going to be. We're designing it for 2 to 6, and we have yet to run tests. But we don't want, when we're pushing this cart system, we don't want the arms to come apart. So we want it to be strong, but we don't want it to be too strong for when you're taking it apart.
Is the sliding makes it easier to separate or?
All right, so the intended way to take it apart, and let's see if I can do it, and it's very hard to represent right now without the silicone housing, is to use the sliding force, but when you're pushing it, it won't come apart.
Right. Thank you very much.